In this video, we are going to study about the method 2 when the pulse ecosystem is failed at some situations. So after that, normal beam pulse through transmission technique. That's a note. In certain cases, the pulse echo technique may not provide required information. So that means the pulse ecosystem also has some drawbacks, some disadvantages. To overcome this, we use this normal beam pulse through transmission test. It happens whenever a defect doesn't provide a suitable reflection surface or whenever its orientation is not favorable for detection. In such cases, pulse through transmission method is adopted. In this method, an ultrasonic pulse from the transducer held at the front surface of the test object and it propagates perpendicular to the surface and it is transmitted through the boundaries of the object and the surface of detects. So the flaw is detected whenever propagation of ray is perpendicular to the surface through this method. So the transmitted pulses are detected by the second transducer held at the opposite end of the test object. Hence, this method is known as a normal beam pulse through transmission testing method. So there is a transducer, if there is a defect, short defect, and if there is a large defect. So whenever the transmission pulse, back echo and at the wall. And whenever the defect will be formed, this will be like this. Whenever the defect is large and the echo will be like this. Let us see what is a medical application. So the medical applications is in a disease treatment. Ultrasonic therapy has been used to treat diseases such as bursitis, abscess, lumbago, etc. Such type of diseases will be treated by using this ultrasonics. And next, surgical use. Using ultrasonics, we can remove kidney stones and brain tumors without shedding blood. That means without loss of blood, we can treat this. Further, we can selectively cut any tissue in our body during an operation by using this ultrasonic use. And next, diagnostic use. Ultrasonics are used for detecting tumors and other defects and locating abnormal growths in our body like brain tumors, etc. In the case of breast cancers, one can identify the state of that cancer using ultrasonics in a non-destructive manner. Similarly, one can identify the twins or any defect in the growth of a fetus before delivery. So during the breast cancer case, if there is an abnormal growth in that part, it will be destructed by using a ultrasonic waves in a destructive manner. So the growth of the baby in the fetus, that also can be detected by using this. And in case of dental cutting, ultrasonic waves have been found very useful for dental cutting because they make the cutting almost painless and there won't be any mechanical device for cutting. Okay, so by using this, it makes the cutting, that's a painless cutting. So there won't be any mechanical device for cutting. Like using a source, using the ultrasonics only, the teeth will be cut. Ultrasonic Doppler blood flow meters are used to study blood flow velocities in blood vessels of our body. So to find the velocity of blood which are flowing in our body, that velocity will be found by using ultrasonic Doppler blood flow meters. So this is the medical applications of ultrasonic waves. Let us see what is the detection of ultrasonics. So the presence of ultrasonic waves can be detected by using the following ways. If there is any sound waves like this above the audible range, we can find it as ultrasonic waves. There are several methods to find those are the ultrasonic waves. Like the first is a piezoelectric detector. By using the piezoelectric effect, we can detect the presence of ultrasonic waves. So when the phases of quartz crystal along the mechanical axis is subjected to ultrasonic, then it undergoes compressions and expansion. The opposite phases, that means in the electrical axis, that will have induced charges which establishes a potential difference. That is, whenever we are applying the force in mechanical axis, the potential difference will generate in the electrical axis, okay, across the opposite phases. So we are applying horizontally the mechanical stress, and it deforms and it produces a potential difference perpendicular to it. So this potential difference indicates that there is a ultrasonic waves. The ultrasonic waves are present in that, okay. And next, this is a Kunst tube method. Let us see what is the Kunst tube method for the detection of ultrasonics. The transmitted and reflected ultrasonic wave in a Kunst tube forms a stationary wave pattern with nodes and antinodes. Let us take a uh, material. Whenever you by using this Kunst tube method, what will happen? The transmitted and reflected ultrasonic waves in a Kunst tube forms a stationary wave pattern. There is a form of nodes and antinodes. Now the lycopodium powder present in the bottom portion of the tube will be collected as heaps at nodes and disappeared at antinodes. So if there is a flaws, it will, the powder, whenever we sprinkle that powder on that particular area, so it will be collected as heaps. That means it will collected at anodes and disappeared at antinodes. So by observing the change in the positions of powder, we can detect ultrasonic waves in the tube only. See how it will be. At node it will be present, and at antinode it will be disappear, the lycopodium powder, okay. And next, what is the sensitive flame method? When a narrow sensitive flame is moved in a medium where ultrasonic waves are present, the flame remains stationary at antinode and flickers at nodes. So this is the testing, simple testing for the ultrasonic waves. If there is any waves, we will test like this by using the sensitive flame method. So the flame will remain stationary at the node positions, and at the antinodes it just flickers, okay, it just flickers. It's stationary at antinodes, and at the nodes it will flickers. And next, thermal detector method. Okay, so when a platinum wire is moved in a medium consists of standing waves of ultrasonics, due to the variation of temperature at nodes and antinodes, the resistance of wire also changes. Okay, due to the temperature, at the nodes and antinodes, the variations of temperature, okay, the resistance of wire will be changed. By noticing the changing resistance of wire, one can detect the presence of ultrasonic waves. Okay, according to the resistance of wire, we can find out the node and antinode positions at the ultrasonic waves. Okay, and next, see how the modes of display. There are different ways of scanning the specimen by using the ultrasonic transducer to get the detailed information about the specimen. Basically, there are three types of scanning procedures to get the useful display. That is the A scan, B scan and C scan. Let us see what is the A scan. A scan means the amplitude modulated time-based scan. Okay, amplitude modulated time-based scan. That is, it's mainly used to determine the location and size of the flaw and measure thickness of the various layers in the specimen surface. So in this mode, by using this mode of display, the x-axis represents the time taken by the pulse to reflecting surface and return back to the transducer. And y-axis, according to y-axis, it represents the amplitude of the echoes. Okay, so now the location of the detect is estimated by the position of echo that's given by it on the horizontal axis and the size of the defect from the relative amplitude of the echo. Okay, and next let us see how the A scan will be. How the voltage and penetration depth, this indicates the transmitted pulse, this is the deflected pulse, and this is the reflected pulse. Okay, and next, B scan. B scan means the brightness modulated time-based scan. So according to the brightness modulation, here the reflected echoes are depicted as dots, okay, on the display screen. Every reflection produces a single dot. So the brightness of the dot depends on the intensity of the reflected of the echo. Okay. So B scan image is a two-dimensional cross-section of the specimen that obtained by summing many A scan echoes and converting echoes to dots whose brightness rises with the strength of the echo. Okay, so the defects can be find out by using these dots. Okay, and next C scan. In the C scan mode, the transducer is moved over the surface of the test piece and the echo intensity is recorded as a variation of line shape. So here the flaw is detected by the variation of line according to the echo. So simply this is the modes of scan and detection of ultrasonics.